This lesson is lesson 6-2, more complex graphs. We are splitting this into 3 separate sections. The first section will cover question number 1 and example A. The second section will cover questions 2 and 3. And the last section will cover question number 4. Let's go ahead and take a look at the beginning. It says examine the graph of the function f of x equals 1 over x minus 2 to the second power, graph below. Describe how this graph is different from the graphs in lesson 6-1. All right, we notice that not linear, right? You probably made note of 2 distinct pieces. So 2 distinct curves that don't connect. And have arrows in opposite directions. Example A has been worked out for us, but let's take a look at it. It says, given the domain and range of the function f of x equals 1 over x minus 2 to the second power, then find the y-intercept, the absolute maximum, and the absolute minimum. To find the domain range, step 1, study the graph. A sketch of this graph is a portion of the function represented by the equation f of x equals 1 over x minus 2 to the second power. 2. Look for values in which the domain causes the function to be undefined. So look at how the graph behaves near x equals 2. So if you notice right here at x equals 2, there's that gap. There's a separation. Now the question is, how did they get x equals 2? Let's talk about that real quick. We set the denominator x minus 2 squared equal to 0. Because remember, your denominator can never be 0. Well, if I square root both sides, I got x minus 2 equals, 0. Well, then to get x by itself, we add 2 to both sides. That is where they came up with this x equals 2. So the domain and range, all right? Well, let's see. The domain are all real values of x, but the only x that cannot be used is 2. So notice how they put that. X does not equal 2. So anything other than that. Let's talk about the range. The range looks like it continues upward, right? To infinity. But it looks like it's not going below a certain point. Can anybody tell me what that point is? It's not going below the x-axis. So we call that y must be greater than 0. None of my y's are ever negative. Now let's take a look at the rest of this question. It says to determine the y-intercept and identify any maximums. Study the graph. We can see that the function intersects the y-axis at 0.025. The value of f of x keeps getting larger as x approaches 2 from both sides. The value of f of x approaches but never reaches 0 as x gets further from 2 on both sides. So the y-intercept is 0.25, and the function does not have an absolute min or an absolute max because they continue on infinitely. Let's look at the try these A together as a class. The function f of x equals 8 plus 2x minus x squared is graphed below. Identify the domain and range of this function. Now, domain, remember, is all my x values. Well, if you look at this is continuing on, and it's going to keep going out as it goes further and further to the left and to the right. So my domain would be all real numbers. And I'm going to put this in set notation. All real numbers. No restrictions, no breaks, no stoppage, nothing. Continues on both directions. Identify the range. Now, the range looks like it goes to negative infinity all at once. But the highest y value that it gets to is right there at 9. So whenever I go to write this in set notation, I'm going to say something along the lines of all real numbers, and then I put this colon saying such that y is less than or equal to, now it looks like it touches 9, anything less than or equal to 9. Moving on to part B. Part B says, identify the y-intercept. Now remember, the y-intercept is where it crosses the y-axis. Right there seems to be my y-intercept. So my y-intercept would be located at 0, 8. Identify any relative min or absolute minimums of this function. Well, because it's continuing on in the negative direction and there's no stop or valley or dip in there, there is no min, either absolute or relative, none. Is there a relative or absolute maximum? That there is, because it's that turning point. And that turning value is at the value of 9. It's the y that corresponds to the maximum position. On to your debriefing question.